In today's tutorial, we'll be doing this it's a VoIP network in which the laptops are daisy changed to the IP phones. So our figure shows the setup of a VoIP network in which each laptop is connected through the IP phone's built-in switch port, sharing a single cable run back to the switch. So although the phone and its laptop share one physical cable back to the switch, they must be kept on two separate logical networks, a voice VLAN for the phone and a data VLAN for the laptop. We are supposed to simulate this network and packet tracer according to the following procedures. We are supposed to 1. Open packet tracer and add the components and then connect the devices in this procedure. The routers port 00 to switch port 1, the IP phones to switch port 2 to 4, each laptop to the pass-through port 0 to its corresponding IP phone. So we go to our packet tracer. On packet tracer, we are supposed to pick the components, the 2811 router, a switch, that is the 2960 route, then devices, which are the IP phones, and the laptops. The laptops are to be daisy chained through the IP phones. So we arrange them in this system, and then routers port 00 to switch port 1, and then switch port 1 to IP phone. And then laptops to the IP phones switch port. So we have completed task 1, which is to connect both parts, and we have connected the phones. We proceed to task 2, which is to configure VLANs for voice and data. We are supposed to create VLAN 10 and name it voice, and VLAN 20 and name it data on the switch. On switch ports 2, 3, and 4, we have to configure VLAN 20 as the access VLAN for the attached laptop, and VLAN 10 as the voice VLAN for the attached IP phone. This allows one cable on each port to carry both VLANs at the same time, tagged separately by the phone. So we have also to configure the link between the switch and the router as an 802.1 trunk, so both VLANs can reach the router. So go back to our packet tracer and start with the switch, and type in the following commands: enable, then config terminal. So we start with interface 1, which is connected to our router. We turn it to a trunk, so switch port mode trunk, switch port trunk, load VLAN 10 and 20. Then we exit, and then we create the VLANs. So VLAN 10, which is named voice, in VLAN 20 name data. And then we're supposed to continue further to configure the interfaces that are connected to our phones. Interface range first limit 0 2 4, and then we're supposed to switch to the access switch port access VLAN 20 switch port voice VLAN 10. Then we exit the interface. So we have completed task 2. We started by configuring the link to the switch, and then we created the VLANs, and then we have configured the switch ports. So we go to task 3, which is to configure the router. So we start with the first task, which is to configure router sub-interfaces for VLAN 10 and 20, each with the correct .1 queue encapsulation and an IP address to act as the VLAN's default gateway. So on our network, we go to the router, and then we start with these commands. So would you like to enter the initial configuration dialog? No. Enable, and then we proceed to config terminal. Type in this commands interface. Shut down. This is to turn the interface on. Then we exit. We continue to interface. First, then it's 00.10 and encapsulation .1 10. We give this IP address 10.12.10.1. Then we exit. Then we continue to interface. First VLAN 0.20 encapsulation .1 Q20. This one we give it IP address 10.10.20.1 subnet. Then we can exit. We continue to task B, which is configure DHCP pool for the voice VLAN and a separate DHCP pool for the data VLAN, each with the correct network and default router. So our network VLANs are number 10 and 20, number 10 being voice and 20 being data. So we proceed to back to Packet Tracer and then put the router. We're supposed to create two DHCP pools, one for the voice data and one for the interface data. So we start with IP DHCP pool voice network 10.10.10.0. Its default router is 10.10.10.1, and since this is the one to carry a voice data, it's supposed to have option 150 IP 10.10.10.1. Then we exit. We create another DHCP pool. Data network 20.0. Its default router is 10.10.20.1. Then we can exit. Then we go back to our question and then proceed to part B, part C, which we are to enable the VoIP telephony services on the router. So back to our packet tracer on our router's interface. We also have to complete one more part before we proceed to creating the telephony services. We must exclude some IP addresses for the router, for the default router. So we IP DHCP excluded address 10.10.10.1 and to 10.10.10.10 IP DHCP excluded address 10.10.20.1 to 10.10.20.10. Then we can proceed to the third task, that is to create the telephony services. So telephony service, enter. So max number of earphones 3, max DM 3, IP source address 10.10.10.1 port 2000. how to assign one, two, three, and then we create CNF files, and then we exit. So that marks the end of creating a VoIP telephony services. So we continue to task 4, which is to configure phone numbers on the router. Create the directory numbers extensions for 3 IP phones. So back to Packet Tracer on our router's interface, we create the first ePhone directory number, ePhone DN phone, we number it 101, then we can exit ePhone DN2, we number it 102, we exit, then we subtract the bad ePhone directory number, and then we number it, we exit. So that's task 4, which is we have created the directory numbers for the IP phones. So we proceed to task 5, which is connect and test. You have to power on the IP phones and ensure they obtain IP addresses via DHCP from the Voice VLAN. Confirm each laptop to obtain an IP address via DHCP on the data VLAN. Check the phone registration message on the router. Initiate a call from one phone to another. Observe call status, ringing, connected and disconnected. So we proceed to powering our phones. Go to the first phone, pick the power, and then drop it. You can see on the GUI the phone is configuring its IP addresses. We power on all the phones on the network. On our router, let's check for this message, which shows that the phones have started registering, which means that one of the phones has registered with an IP address. So this is directory number 101. As you can see, another IP phone has also registered, and the third IP phone has registered, and they have obtained IP addresses via DHCP, that is name IP address 11, 12, and 13. We proceed to our laptop, which is supposed to use DHCP configuration. They have also acquired automatic address by, which is .10.10.20.11, and the DHCP request was successful. So they are using the laptops, and the IP phones are on different IP addresses, with the laptops on .20 and the phones on .10, showing that they are on different VLANs. DHCP automatic. Proceed to the last laptop. DHCP request was successful. So if I highlight the phone, you can see that it has acquired an IP address of .10.10.10.10.12, where the laptop connected to that IP phone has acquired an IP address of 10.10.20.12, and it's using gateway 10.10.1, where the IP phone is using gateway 10.10.10.1. So we're supposed to test for calls. So then for 103 we can call number 101. So we can see it's ringing out to the phone. So we go to phone number 101. We have connected. It's now connected. We can now send test tunes. The line is disconnected. We can call number 102 from this line. You can hear it. We can hear phone number 102 ringing. On our GUI, you can see we have the phone is ringing from 101, which has now connected. We can now send dial tunes back to phone 1. So that marks the end of our tutorial.